Hello everybody, I'm Adam. In this problem, for the ellipse, which we're told has vertices at points positive and negative 5, 0, and foci at positive and negative 4, 0, we're going to use the results for some previous exercises to try to find the parametric equations for the conic. And one of the results that we have is that for an ellipse with a horizontal major axis, the parametric equations can be given as x equals h plus a times cosine theta and y equals k plus b times sine theta. So we'll see how we can make use of this, or if we can. So first off, we're not going to sketch the graph of the ellipse, but it's good to kind of plot things out just to get a visual idea. So we're told we have vertices and foci of our ellipse. All right, to start with, we're told the vertices are at positive and negative 5, 0. So if we think on our x-axis, distance 5, and negative 5, so we have our two vertices here, positive 5, 0, and negative 5, 0, and our two foci at positive and negative 4, 0, Okay, so just getting a visual and looking at this, what does this tell us? First off, since our vertices are on the x-axis, well, that's where our major axis is going. So we have a horizontal major axis. So we can use the result of these parametric equations over here. So with these parametric equations, looking at them, well, we need the values of h, k, and then a and b. So what can we get from this? Well, based on where the vertices are at, or foci, likewise, the vertices are at 5, 0, and negative 5, 0. So first off, that tells us our distance a, or what we can find, from the center point, which would be in the middle of those, so our center point hk is at the origin 0, 0, and that namely tells us that a, the distance from the center out to the vertices, is equal to 5. So we have enough to kind of get started. So our first parametric equation, x equals h plus a cosine theta, x is equal to h, which is 0, plus a, or 5 cosine theta, or we have that x is just equal to, say, 5 cosine theta. Now for y, we have that y is equal to k plus b times sine of theta. So we know k is equal to 0, but we don't know what b is. Now how can we find b? Well, we have a relationship, namely that c squared is equal to a squared minus b squared. And we know what a is, and since we also know the foci, we know what c is. All right, so c, again, is the distance from the center to the foci. So c is equal to 4. So plugging into here, we have that c, or 4 squared, is equal to a squared, 5 squared, say minus b squared. And now we can just solve for b. So 4 squared being 16, minus 25, or 5 squared. So we have 16 minus 25, or negative 9, is equal to negative b squared. Of course, our negatives will cancel. And so taking the square root of both sides, this is going to imply that b is equal to square root of 9, or 3. So then our parametric equation for y, again, is y equals k, or 0, plus b, which is 3 times sine of theta, or y is equal to just 3 sine of theta. And so there's the set of parametric equations for our ellipse. Thank you very much.